I never ask you on a test just a straight definition question. I never say, like, define sample or something. I hate that. I make you use the terminology correctly. So, and when I discuss this, I try to make it a little less dry. I try to give a story to it. So what is something about Grossmont students that you might be interested in knowing? Like a boring one would be the percentage of Grossmont students that smoke or something, right? Or the average age of Grossmont students, right? So what is something that you might like to know about all Grossmont students? Anybody have anything? Yes? Average height. I love it. It kicks ass. All right. So let's say we want to know. Might as well set you up now with, yes, I do write that horribly. Actually, it's a little more horrible today. I think I'm out of practice. We want to know the average height of Grossmont students. Now, to be honest, I would probably say the average height of either male Grossmont students or female Grossmont students. And why would I do that? Because there's such a difference between the two. They are basically two different populations when it comes to the idea of height, right? So which one do you want to say? Female. Okay. Got it. Female Grossmont students. One reason I like that is that's one question I ask you on a survey is what's your height? And then we're going to analyze those heights for like good data. So that's what we want to know. So already there's several things I can unpack out of this. There is a population that I want to say something about. And what is that population? Yeah, all female Grossmont students. You guys with me? So there's a large group, an entire group I want to be able to say something about. And let's say that it's us. What kind of resources do we have to gather data about this? Not very good, right? We're not going to go somewhere and say, can you give me a list of all the female students and their heights? I don't think somebody's going to go, of course. I mean, like, who the hell are you? So what are we going to have to do? Do we have time to go measure every Grossmont female student? Female Grossmont student, there it is. Yeah, so we have to pick a subgroup, something called a sample, right? So we have a whole group that we want to say something about. I feel so bad for you guys. A group that we want to say something about, and then we have a subgroup that we're actually going to work with. Now, sometimes we could work with the whole population. If my population was everybody in this room, I could just work with you guys, right? In this case, all the females in the room. And then we have a subgroup called a sample. Let's say, so how would I, these are the people that we're going to actually analyze. Subgroup of the population we actually analyze. All right, everybody with me so far? Now, most of the time people know these words for the most part. You know, especially the word sample. You know the word population from a lot of different places. How am I going to pick this sample? If I just pick all the females in this classroom, why might that not be a good sample? I love it. So it's not random. So we're going to get into what makes something random. But really, why is it not random? You're all the females in here. There's nothing wrong with you, right? As far as I know. I don't know you that well yet. Right? But why would you not be a good sample?
Because not all female students in the whole school.
But we already said we don't have time to talk to everybody. We're only going to take a subgroup. So what's wrong with a group of women in this room?
It's biased because people in here are doing better social statistics. It's not the average population.
Yeah, it might be biased somehow. Now, height's a little bit weird, but still. It might be biased somehow because why are you all here? You either have majors that require statistics or you just chose to take statistics. So there's a much more detailed definition about what makes you guys not a random sample. You're not bad people. You would just be a bad sample. Right? So, yes? Oh, well, we could go back and change our population. But we can't really. We want to say something about, yeah, but the subgroup. So here's the thing. If I want to say something about everybody in the United States, and I pick 800 people from Wyoming, why is that not good? Because it doesn't represent everybody in my population. Now, I don't have to use everybody in my population because we already said that we're not going to do that. We don't have time. Shit. Let me go around the United States. Here we go. 12 years from now, I haven't made it out of California. Right? You guys with me? So for this, the reason that you guys don't make a good sample is you're not representative of the entire population of gross white female students. You guys with me? So that's what would make it random if it was truly representative. But how do you, now let's dig a little deeper. How do you make it truly representative then? What's got to happen in order for it to be truly representative? I can't use everybody. We already said that. Too many female gross one students.
Female students must take that class.
So this is not a class they're taking. They are just all the gross one students.
Well, in order to use a sample, all females have to be going through that class.
But how do we pick those people? That's the true. Well, no. Does everybody have to take English that goes here? No. They could place out. They can come with AP credit, whatever. Right? Yes? Which classes?
All classes. Remind me by ID number.
ID number, I like it. Okay. So yes? Some student, well, yeah, I guess you can call undecided a major. Right? Got a master's in undecided. All right, so we got a few different options. But the key, so I had, somebody said pick 2 people from every class that's running. You with me? That's nice. Somebody else said randomly by ID number. So maybe have now then we have to get access, but you get a list of ID numbers, and then there's a lot of different ways to do that. You can cut them up, put them in a hat, pick them out. You can take every 7th one with a random starting place. What's really cool is this is going to come back later with when we talk about types of sampling. And then you just said, I'm sorry, I forgot already.
By major.
By major. So again, it's sort of like breaking them down into groups and then picking some from those groups. The classes, the majors. That's one idea. But the thread between all of those is it isn't random if there's something in the population that had no chance to be in the sample. So in order to be random, do you see how slow I start talking sometimes? That's when you know it's a good note. In order for a sample to be random, everybody in the population must have an equal chance to get into the sample. So that's why you guys are not a good sample. Does everybody have to take stats? No. Does everybody take stats in the intersection? No. I mean, you know, do you see what I'm saying? All right, so some specific things would be, I like the ID number thing, that you definitely wouldn't miss anybody. The by major thing might be a little bit hard, but it still wouldn't miss anybody. The 2 from every class that's being offered in the spring semester, that would definitely work. You could argue that if you don't come to class, but it's your choice, or you still have a chance to be in the sample. Do you see what I'm saying? But the key aspect to make it, so this is a subgroup to be random every, let me get a little mathy on you, every element in the population must have an equal chance to be chosen. The club. Sorry. So how are we going to pick our sample? Let's just say, see? I like it. So we get a list of ID numbers. Now he's going to have the ID numbers of just the females. That's good. Okay. I like it. So you're not really a student here until you're given an ID number. So I like that. Because if you said, I'm going to stand out on the sidewalk and pick every 7th female I see, that's got a lot of issues, not the least of which, there are a lot of people walking on campus that aren't even going here. Right? They're just here for other reasons. So you're not really representing your population if you're picking people that aren't in your population. All right, I like it. How are we doing so far? Is everybody good? All right. We're 2 words in. All right. Okay. Now, what am I going to do with this sample? What am I going to do the minute? So let's say we've already got our people picked. How many people do you think I should choose? Do you know how many people go to Gross Month? So I'm not just talking about intercession, because then I'm talking about spring, which intercession is a part of. It's roughly 20,000 people that go to Gross Month. So how many people do you think I should pick in my sample? Yeah, 500, 1,000. I like that. Those are both decent. There's a website called Gallup.com that I'm going to show you in a little bit. I'm pointing to my screen because later I'll put it here. And they normally use 1,200 or so. So let's say we choose, so we're going to use 500 females chosen this way. Now, to be honest, 100 females would still be a good sample if I chose them randomly like this. Right? Even less than that could be a good sample. Believe it or not. All right, I like it. Okay, so the minute I get that list of females and I go and I talk to them or I measure them, whatever, I either take their word for it, look at their driver's license. 6 feet tall, huh? Measuring. What do I do with that data then? In fact, let's talk right now. The minute I said that, obviously the very next thing I do is, I already told this to you, I collected data. That's another word. Shit. And actually, let me put this as number 4. Sorry. Number 3 is the variable. These kind of go in order. So the third thing is the variable. And that does sound very much like algebra, and that's for a purpose, a reason. And then the 4th thing is the data. The thing I love about this little pairing of things, the variable in this case, what can vary from person to person? Obviously, in this case, it is their height. That's why it's called a variable, because for each element of my sample, it could be different. Just like the possible values of x in algebra. I like it. So that's why it's called a variable. The variable is related to the question you would ask. Bam. So they ask you in the homework, what's the variable in this situation? Just think, if I was doing this, what would I ask? Or what would I measure? Or what would I look at? Do you guys understand that? The variable is related to the question that you ask. The data would be all of the answers to that question. All the observations, all the measurements, all the answers to that question. All right, let me stop there for a second. I always think that kind of way of looking at it makes it very easy then to answer problems about what's the variable. What would I ask you? Give me an example of data. What could be an answer somebody would give me? That's how you figure out that kind of problem. Okay, I like it. Let's see. Okay, now, so we got what the hell do you want to say something about? Who do you want to say it about? who are we going to work with? This is all about how are we going to work with them? What kind of stuff can we get from them? And now, what am I going to do with this data? What is it we wanted to know in this specific case? Yeah, I want to know the average height of female Grossmont students. Am I going to get that from this study? No. I'm going to get the average height of 500 of them. Am I not? Right? So the thing I want describes the population, and the thing that I very often get describes the sample. Now, how much am I going to trust what I find from my sample? Well, it deals with two things. How large my sample is, and if it was truly randomly selected. Right? If I just pick the people I know, well, that sucks. I can't trust my results. Are my results always going to be bad then? No. I just can't trust them. I don't know if they're good or bad. True, but I have to repeat it in a better way. I'd have to make sure that it's randomly selected. Right? So it needs to be randomly selected, and the other thing I just said, went right in my head. Oh, and the size has to be decent. I can't just talk to 5 people. 3 to 4 dentists, and we only talk to 4. Well, shit, screw that. You guys all right? 100% of the people we talked to like this product, and that was one person that talked to. Yeah. All right. So what am I going to do with this data? I want to get what's called the parameter. You got to love what's about to happen. You have to. The parameter is a numerical measurement that describes the population. Parameter, population, right? Numerical measurement. It could be describing the population. It's normally either a percentage or an average, but it could be more than that. But that's the two things it normally is. Numerical measurement describing the population. Again, population parameter. So the thing that describes the sample, I would love it if it started with the letter S. And it does. It's called the statistic. Holy shit. The 6th word we're talking about is the title of the class. Statistic is a numerical measurement that describes the blah, blah, blah sample. The less I write, the better. It's a numerical measurement that describes the sample. So part of what we're going to learn in this class later is, in fact, let me see. We're in between election type of stuff. Anybody a big election or political wonk? You like to look at election possibilities and so forth? All right. I'm trying to stay away from politics. A few years ago, I used to joke that it's going to become the point where you go to a barber and you have to ask them what their political ideology is before you sit in the chair. Oh, you're that? Screw this place. We're basically there now. So I just try to keep politics out. I'm human, so it's going to leak out. So I'm just going to, especially nowadays. Oh, shit. All right. But whenever you see like 40% of people want to vote for candidate A and 44% of people want to vote for candidate B, you see that on the screen or you see that in an article. Is that definite? Of course not. You always see the bottom, plus or minus 4%. So what we want to do, and we're going to actually figure out the formula that comes up with that number. They don't just come up, well, to cover our ass, let's say 4%. Okay. No. There's a formula that you can use. And believe it, and it makes sense. The formula requires you to know the sample size. The bigger the sample, the less uncertain I should be. So that number will get smaller as my sample size gets bigger. And you can actually see it in the formula. So we will learn that later this semester. But so I normally can get a hold of this, and then I do what's called, I infer this. So I talk to a group of people, and 40% of them want to vote for candidate A, and then I go, all right, 40% of everybody, give or take 4%, wants to vote for candidate A. Do you guys see what I'm saying? I use it to infer something about the population. Normally I have to kind of show my uncertainty in that, right, to be honest. All right, how are we doing so far? So what I love about statistics, it's the most honest math. algebra is required. You have to know how to manipulate stuff, but it kind of sets you up to think that everything has an answer, which is so not true. In fact, there's a whole range of chaos theory and fuzzy math and all that kind of shit that's a little bit more true to life. So statistics is always like, there's a chance we're wrong. That's why I love it. That's why people give up on it. Like, it's not giving me an answer. Well, yes, it is. It's the best it could do. I'd rather know my surgery has a 95% chance. I'd rather know that of being successful than just like, 50-50, you know. I'd rather be able to have somebody calculate, make me feel a little better, at least let me know what I'm getting into. All right, maybe. By the way, real quick, my little brother always jokes me. He says, "You're still teaching probability, Jeff?" Yeah. He's like, "It's all shit. It's either going to happen or it ain't. It's all 50-50. I'd say, "James, thank God you didn't become a doctor, man. Or weatherman. 50% chance of snow in downtown San Diego." No, come on. It's either going to happen or it ain't. No, that's bullshit. Right, so I understand what he's thinking in a way, because he's very practical, he's very pragmatic, but this is about preparation, not response to something, right? Okay. Let's see. Oh. You guys doing okay so far? So this is the big, we're going to see these words throughout this semester. Let me take a minute. I want to show you a problem related to this right now, just to alleviate some possible early confusion. I'm going to put it up here. Okay. I still have the book up here. Yes. Oh, let's see. What did I assign to you guys? 44 and 48, so we'll do 42. I like it. Oh, you can't see shit. All right. All right, see number 42 there? Can somebody turn off the one that says whiteboard and the one that says outboard? I think it's outboard. That does. All right, thank you. So number 42. Oh. Hey, you want to take a second?
If that works for you?
Yeah.
Okay.
I won't make you stand
So
back.
you let me know what's up.
Good time for this.
Okay, awesome.
Oh, I can sit down for a second.
See, I help however I can. So my name is Mark. If you don't know me or don't recognize me, I've gotten that a lot. And I work in the Math Study Center. So when I start this spiel, my first question is always, is there anyone here that does not know where that is? It's totally cool. Yeah? Okay, awesome. No worries. So if you go into kind of like the tech mall where all the computers are all up the stairs, you go into the room. Instead of sitting down at one of the computers, if you go along the left wall, you'll see a sign that says 70-112, and that is where the Math Study Center is located. So during intersession, normally in the fall and spring we have lots more hours and stuff like that, but there's only 3 math classes being taught right now, so we've kind of squashed things down. So I'm going to be in the Math Study Center for you guys Monday through Friday from 11:15 to 2:45 p.m. Okay? So if you guys need time to study or have questions and whatnot, you can come on by. I'll be there to help you guys out as best I can. We have books and we have calculators for you guys that you can check out if you happen to leave supplies at home. You just can't leave the room with them, so don't bring them to class. And let's see, what else am I forgetting? Oh, I also wanted to state one of the things from my own personal experience, and you can interject if you disagree, but I feel that stats among the math classes is the one that's taught most differently between all of the classes. And so I would really appreciate if you guys come for questions or whatnot, if you bring your notes, if you bring your tables or whatnot that you'll know about later in the semester. That way I can make sure that I'm guiding you not just to get the right answer, but also to be done in the way that you guys are seeing in class. Because if I confuse you, I'm not being helpful, right? So that's just all I had to say. Are there any questions?
What was the times again?
11:15 to 2:45. Yes.
Will you definitely be in there until 2:45?
I will.
Kathleen said there's a chance that you guys would leave early if nobody was there by a certain time.
I have not heard that yet.
Okay.
I've been told that I know she's leaving early today, so you know.
We're gonna swing by
I just
tomorrow,
feel-
so.
Okay.
Yeah.
Okay. Yeah. Yeah. I mean, I'm just gonna bring other stuff to do in case no one shows up. That way I don't have a reason to leave.
Gotcha, okay.
Yeah. So yeah, I'll be there till 2:45. All right.
Oh, that's perfect. I like that. Okay. So this problem, I love this problem, but it's also one that gives people the most trouble. First thing. There's a series of problems. They all ask the same questions. Identify the population, the sample, parameter, statistic, variable, and data. Give examples where appropriate. Okay, so let's try to do number 42. So 42 says a fitness center is interested in the mean amount of time a client exercises in the center each week. So what is their population? The clients of the fitness center. I love it. Clients of the fitness center. Beautiful. That's the population. Now, one thing that confuses people about this problem is you have a leeway in how you define the sample. But if the population is all the clients of the fitness center, one possible way to say the sample is just to say some of them, a subgroup, random selection of clients. You could even be specific and say 100 randomly selected clients of the fitness center. You have some leeway on part B. So people get confused because they're like, it doesn't say anything about a sample, but it's as if you're the ones going to do the study. You can say it how you want to. A subgroup that we select randomly, or you could be more specific. Are you guys with me so far? It's all about, do you understand the definition well enough to use it? That's what I'm looking for. What's the parameter? In words, what's the parameter? And parameter has to describe the parameter describes the population. Right? So what would the parameter be here? No. What are they interested in?
Time.
There you go. The average or the mean, and mean is just another word for average. It's the more mathematical term. So the mean amount of time that a client exercises in there per week, right? You guys, the mean amount of time that the clients exercise in there per week. What is the statistic then? The mean amount of time that the people in the sample, the clients in the sample, do you see how they sound exactly the same, except one references the population, the other one references the sample. So however, if you would have said in part B, if you would have said 80 selected clients, 80 randomly selected clients, then your part D would be the mean amount of time that the 80 selected clients spent in the fitness center per week. You reference the population if it asks you for a parameter. You reference the sample if it asks you for a statistic. And they both sound almost the same. It's just that instead of the word all, you put a number or the subgroup or whatever. How do you guys feel about that? That's the basic idea about parameter has to describe a population. So you better reference the population. Statistic has to describe the sample. So you better reference the sample. I love it. What's the variable? I love it. How much time each client spends exercising. And then the data, that's where I would give examples. What are examples of the data? 8 hours, 0 hours, right? Somebody just joined and they're like, yeah, I belong to a gym, but they never go. Or the people that live there, right? There are people that, anybody go to the gym? You could be one of these people I'm about to talk about, but there's people that no matter what time I go, I see them. And it freaks me out a little bit. I'm like, are you here all day, every day? I don't understand. Anyway, all right. I'll let go. Sorry. Is everybody? Yes. Oh, the variable in this case would be the amount of time that a client. Yeah, exactly. So the variable is the question you would ask somebody in the sample.
The statistics is the average amount.
Yeah, the statistic is the analysis you do.
Okay.
So the parameter in the statistic will almost always be a percentage of blah, 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 blah.
Okay.
Or a mean or average of blah, blah, blah. Because that's the analysis you do. I like it. You can tell some of you guys are like, oh shit. But I desperately want you to realize, I mean, again, we just started talking about it today. So you got to look at it, try it out. Okay? You guys feel okay about that? I don't want to let you just get into this problem not having a clue what to be careful about. So a couple places there where you can just totally make up your stuff, but it's got to make sense. Yes? So the parameter here would be the mean amount of time that all clients exercised in there per week, because that's what they want to know, all the clients. And so the statistic would be the mean amount of time that the clients in the sample exercise there per week. So if you think about it, almost every problem in this section would have almost the same answers in a way. Okay, we'll see how that goes. Okay, cool. All right, let's see, where do I go from there? I think now, I'm going to do one more section's worth of definitions. Then we'll take another little break, I think. Yeah, here we go. Cool. I like it. Yeah, beautiful. So let's talk about, let's break down the variable real quick. The data. So data can be broken down in several different ways. The most basic way to break down data. So one data point I could take is your heights. That's one type of data. Another data point I could take from you guys would be your hair color. Right? That's a different type of data. Those aren't the same types of data. What can I do with heights that I cannot do with hair colors? For example, I can compute the mean, right? How do I compute the average hair color? They're not numbers, they're just freaking names of hair colors, right? So there's one type of data would be qualitative, and the other type is quantitative. I think this book actually calls it, oh good, this book calls it quantitative. There's another book that called it categorical, which kind of goes away from the nice symmetry here, but oh well. It actually is a little more direct as to what qualitative is.
Quality.
There's a quality, like hair color. It's categorizable, right? It's names. So this is truly names, categories, not truly numerical. What do I mean by truly numerical? Well, I could ask you for a team the jersey numbers of people, right? Are those true numbers? No, they're names. Your social security number. It's not truly a number. It's another name for you, right? So if I said there goes number 17 down the side, well, that's his name. That's the guy's name. At that point, it's another way to reference that person. That's a name. One semester, I had some people from the basketball team, and it said if you add Michelle's jersey number to Sally's jersey number, that doesn't mean anything. And they said, yeah, it does. You get her, because it was like 12, 14, and 26. I was like, shit. But you understand, if you add jersey numbers or if you average jersey numbers, they ain't gonna mean shit. They're not real numbers. Okay, you guys, semi with me here. So the quantitative is truly numerical. They're measurements, they're numbers in the sense that if I add them or average them, it makes sense. So they do all the stuff that true numbers are supposed to do. If I take zip codes and do something with them, add them together or something, it doesn't mean a damn thing, right? They're not true numbers then. They would be qualitative. They're name of an area. This is what I call hopeful Tai Chi nowadays. I used to do this all the time. Now I do this. Okay, so that's not too bad, right? That's like a hard line there. Numbers, not number. Okay, I get it. So let's get to the part that's a little less well delineated. Oh shit. There's a further way to subdivide data. Levels of data. Okay. So there's a level called nominal. Somebody ever heard the phrase plume de nom? Where are my readers at? Like Stephen King, when he first started writing novels, went right out of my head. He went by a different name when he first started. It was what's called the plume de nom, his pen name. Plume de nom. Nom is nominal. Nom is name data. People say nom and they think number. No. So which one does this fall under here? Qualitative. So nominal is pure name data. I can't subtract them. It's not numerical at all. There's not an order that they want to be in. So if I said, go tell me what types of cars are out in the parking lot, and you say, well, I saw a Hyundai. I just like to say Hyundai, and a BMW and a Ford. I wouldn't go, whoa, it's out of order. You didn't put those in order. No, who cares? Alphabetical order is something I can impose. It's not something it has to be in. So this is just name data, like hair color, type of car, or vehicle, blah, blah, blah. The next level adds something to this. So it's still name data, but it's got an extra thing to it. So the next level is called ordinal. And the root word of that gives it away. There's a certain what to it. Order. So if you went to a restaurant, one of these restaurants that had a little thing on the table that says, please rate your experience with us today, right? And it said, your experience was good, horrible, how do you spell horrible? Fair, excellent, You're like, wait a minute, what the hell? That's out of order. This shit. Or if you had to fill out an evaluation for a teacher and it went agree, strongly disagree, strongly agree, neutral. You're like, what the shit are you trying to do? Do you understand? Those are names of how you feel about something, but there's an order they have to be in to make sense. Alphabetical order doesn't really count for that. That's an order you can impose, but does it have to be in that order? No. So don't say, yeah, I could put it in order. Well, I could put anything in order of anything, right? An order of how I like it or whatever. But does it have to be in order for it to make sense? That makes it ordinal. So it's name data that has an inherent order that it wants to be in. So I love the looks like it's something like, I almost, no, screw it, I don't know what you do. So it's like when I want to rank something, when I want to evaluate something, I want it to be a scale. But it's not a number scale. It's not like a number line, but it's a scale of worst to best, right? That's a really good example. So some kind of ranking would be ordinal. It's still a name. You could say, oh yeah, that's that horrible restaurant over there. And that one's fair. That one's good. That one's excellent. It's their name, but it has to be in order when I'm trying to give that name to them. It has to be in order for it to make sense. So ordinal names with an inherent order. Okay. I love it. Again, these looks like the shit have I gotten myself into. But again, this is really a section we have to go through. You got to read. You got to try the problems out. You got to come tomorrow with questions from the homework. Okay. So these two are basically qualitative. The next two are basically going to be quantitative. So if I have a problem where it's a name data, it's a category data, I'm only going to worry about figuring out which one of these two it is. If it's a truly number, if it's something I can subtract or divide or do something, then I'm going to worry about the next two levels. Okay. So I'm going to put both of these levels down at once because it makes more sense to talk on both at once. nominal, ordinal, and then there's interval. Oh my God, Jeff, try that whole word again. Interval and ratio. Now both of those are very mathematical words. Interval notation. You guys remember interval notation from 7 to 9, not including or including? Oh shit. Oh boy, that's not what I'm talking about exactly, but it's sort of related to that. Interval data is data that when you subtract them, the answer makes sense. So again, if I subtract 2 jersey numbers, do I get an answer? Yes, I get an answer. Does it make some kind of sense? No. It doesn't. It doesn't mean something, right? But if I subtract 2 years, like if I subtracted the year I was born from the year you were born, what would that tell you? How different in age we are, right? It would have a physical meaning. You guys with me? So, interval is where subtraction, not just can you do it, but does it make sense? Subtraction makes sense. Yes?
Is it only subtraction or like is it only subtraction or like addition? Does that make sense? Or just subtraction?
Only subtraction. I like it. Now, ratio is what kind of operation? When you create a ratio, it's a what?
1.
It's like 1 over 5 or 10 over 2 or something. So that is, of course, what operation? Over is division, right? 10 over 2 is, oh my God, there's my 7th puberty right there. So ratio, the word ratio is from fractions, right? Rational stuff. So that tells you what the hell this means here. It tells you division makes sense. So if I took 2 things actually. Division makes sense. And 0 means what it should mean. So division makes sense, and 0 means what it should. What should 0 mean? The absence of that thing. So how many temperature scales do you guys know? 3. How are you doing there? Are you about to have your break? Well, we'll see. Oh yeah, people in the front row, wherever I put the camera, if you just let me know if it shuts off or something, that'd be much appreciated. Okay. Has a little union break it takes every now and then. What did I just say? Oh, temperature. A lot of you guys know 3 temperature scales. That's awesome. Some of you guys are like, what the shit are they talking about? I got my Fahrenheit and my Celsius, but of course there's Kelvin. I like it. Kelvin is the measurement of energy. So when you hit 0 Kelvin, that truly means what it's supposed to mean. There's no energy. We're all dead. Right? I like it. I'll stop. I did some graduate research about taking atoms down to almost 0. You've heard of absolute 0?
Yeah.
So we took them almost 0 and then like overlap and make this giant atom. We're trying to make a maser, which is a matter laser. I'll stop.
See the thing where they actually got like
Sounds cool.
the negative Kelvin for things, because it's like they have things so almost like no energy that putting energy in, or I think it's where everything has stuff, but there's like a couple atoms that have no energy. If you put energy in, it makes the system more stable. So technically,
Oh, okay.
negative Kelvin,
All
it's pretty
right.
rad.
It's like a different way to define negative Kelvin, but yeah, okay. Anyway, all right, that's enough of that, sorry. Don't let me start talking about my research. So for example, Fahrenheit. If you get to 0 degrees Fahrenheit, is that the absence of heat? Can you get colder?
Yeah.
Yes. So 0 doesn't mean what it's supposed to mean. So is Fahrenheit or Celsius? Are those data points ratio or interval? Interval. Because you can subtract. You can say, well, today is 3 degrees warmer than yesterday or whatever the hell it was, right? But if you divide the 2, the answer doesn't mean anything. One reason that the answer doesn't mean anything when you divide is that 0 is not in the right place. What's twice as hot as 0 degrees? There is something that we can kind of say, yeah, it's about twice as hot, but twice 0 is freaking 0. So if 0 is not in the right place, it can't be ratio. What about profit of a company? What level would that be? Profit of a company. Some people think it's interval because you can go negative, but that doesn't mean shit. Does 0 mean what it's supposed to mean? If you had 0 profit, does that mean the absence of profit? Yes. There you go. If I made $2,000 last year and $4,000 this year, I am now making twice as much. Right, or the other way around. I can't remember what I just said. You guys, so the ratio, when you divide the two, the answer makes sense. So it's ratio. I like it. Okay. So there's those 4. I like it. So let's you guys ready for another break, or what time is it? Yeah, let's take another little break, and then no more breaks for today. How long of a break you want? 15 minutes? 10, 15. Come back at 11:20. I like it. Who just came in?
You want me to stop it?
Thank you.